we were discussing cell reselection and handover. And uh, this both types of occurrences we can call change of cell. Now, for any type, either cell reselection or handover, a decision has to be made that when I perform that particular action, a change of cell should really perform. And that depends on the radiolink quality. It's actually a relative radiolink quality, but sometimes it may be, some other threshold values may determine. Uh, but as a, in general, we can say that it's a relative radiolink quality uh, between the primary serving cell and the other cells that you can see around. So it's it depends on the radiolink quality experienced by the EV. You can hear me, right, guys? Can you hear me?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So so the in the area, the coverage area, the radiolink quality varies from point to point. At different positions, you have different types of, the qualities are different. But the at the position of the EV, uh, the radiolink quality, the relative radiolink quality dictates or what the EV itself experiences. So whoever makes the decision, he has to know how that is experienced by the EV or how that is at the position of the EV. Okay. If the EV is the one who makes the decision, then it's straightforward. Okay. It experiences and it itself has to make the decision. So from its experience, it can make the decision. But if it is the network who has to make the decision, then how come the network knows, okay, what how the radiolink quality is? So in that case, the EV has to inform the network. So there are two types of there in the procedures. Uh, there are completely different. I mean, there are differences. And you see in which procedure applies to which case. But before that, another thing we want to mention, last time we said, but now formally I included, that the reading in a secretary.
Hello.
Sorry for the break. The radio link quality, or I mean the radio signal level, keeps varying, keeps fluctuating with the multiple environment. So this time varying nature of the radio signals uh, make things so fluctuating that suddenly you can find another cell better than your current one, and after a short while, the previous cancer uh, which we are calling current cell, can again seem better. So since radio signal is varying for all the cells, the experience uh, has a in the experience finds the relative position also varying, okay, varying very fast. One may be better in just a short while, another one may seem better, the third one may seem better, and then the first one may again seem better. So if you trigger the change of cell right away, just when another cell on better, then there's a big possibility that the older cell will again seem better and you will want to switch back to the old cell. This is if this really happens that you are moving back and forth very fast, then it is called ping pong. And this ping pong effects are undesired. So it's unnecessarily you are performing some actions which, which can consume resources. Well, I say that there are two types of procedures. Okay. So if it is the procedure where the E makes the decision, then the, the radio resources are not consumed, but some processing power you use at the EV unnecessarily. On the other hand, for the second type, you actually consume some resources too. So the ping pong effects are undesired, and to prevent ping pong, some margin is used as we see later. Now the two types will actually clarify. The two types are cell reselection and handover. I actually already mentioned. And in RC idle state, first step occurs handover, and in RC connected state, the second step handover. Now about measurements. Okay. Since the decision whether cell reselection or handover should take place depends on the relative radio link quality. The radio signal level has to be measured. And who can measure it? The E has to measure it because uh, we need we need how it is at the position of the E, what the E itself is experiencing. So the network cannot measure. The E has to measure. Now who makes the decision? In the case of cell reselection, it is the E who makes the decision, and in the case of handover, E not to make the decision. Let me tell you why. Well, while we were discussing tracking area or paging, we say that the E may be moving through different cells, but it doesn't update the network until it changes an area, enemy pool area, or an area covered by TI list. So, because otherwise there would be some wastage of radio resources. So you may not be making any call, but you may be moving through many different cells. So why update the network as the update procedure might, would definitely consume radio resources. So that's unnecessary. Unnecessarily you don't do that. And if the network is not updated, then the EV itself is doing everything. The EV makes the decision. Okay, change the cell. We select the cell. Select another cell. Just change your serving cell. Now another cell is better. Is better. So select this new one as a serving cell. So the network doesn't know about it. So this is what happens in the case of RC idle state. But in RC connected state, the network has to know, because the radio resources may be allocated, some data transfer may be going on. So radio resources may be allocated in the new cell, the data would be routed there. So the EV, the network has to now allocate the resources the right place. And if that is the case, then it has to be coordinated by the network. Okay. Say the next cell that you are going to may be already overloaded. Okay. But a third cell may also be pretty close. The radio link quality may not be bad from a third cell, and the third cell may be underloaded. So the network may decide that instead of the second cell, which may be the best in terms of the radio link quality, is not the one that you are handed over to. Rather, the third cell is selected for handover. So it has to be coordinated by the network. And eNode B takes, is involved. Actually, from the core network, and the decision is taken. Uh, there will be negotiation between the neighboring in the neighborhood. So, the decision itself, within the RAN, the decisions can be taken, but from the core network, there is involvement at the core network because the data path has to be switched. But within the RAN, within the eNode base, the network, the decisions can be taken. But how the eNode base make the decision, as I was saying, the eNode base has to know how the radio link quality at your position, at the position of the UE. So the eNode UE has to inform, and that's called measurement reporting. Since some RC messages called measurement report to the eNode base, and which includes the relative radio link quality, the radio link quality information of the serving cell and for the neighboring cells. So it detects the neighbor cells, measures their radio link quality, and it creates a list of all these things, send it to the eNode base, which is called measurement report. Measurement report has includes a number of records. Each record is the the cell identity PCI, and then its radio link quality. When the network feels that handover should be made and the cell is now much better by a margin, we could pretend inform the margin will be allowed. So and the cell has been staying better by a margin for a while. So we can send a command, switch to that cell. Command from So now we'll go through these procedures in detail, and actually the first part, cell reselection, has already been covered. Okay, and these are three types. Okay, and these three types also apply to handover. See that there are some priorities are given. Well, by priority, I mean that say there can be a number of other frequencies for deployment. Say 320 megahertz deployment can be there. So if you switch to another 20 megahertz deployment, that will be inter frequency. Okay. So there can be different frequencies, and they these frequencies are informed. The network tells what frequencies are available. So if there are say 3 other frequencies deployed on top of each other, then all these 3 frequencies will be notified on your current frequency in your current cell. Okay. So with the SIG type that does it is SIG type 5. But when it informs like that, or each of these frequencies, it gives some priority. Priority. The priority is a number from 0 to 7. So similarly for inter-rate cell, inter-rate is also priority. Now, how they are handled? If the priority can be better, higher from your time, from compared to what your current priority is, that can be lower. So let's see how it is dealt. Cell selection we discussed. Okay. This is the condition used for, we discussed last time. This is what you use for cells on your on the same frequency, intra-frequency cells. You rank RS and RN, and also you use the same formula when you find another cell on a frequency that has equal priority. Okay. I mean, you have particular priorities, maybe the priority number 5, but you can have any number between 0 and 7. It may be 5. So you find another cell which is on a frequency on priority 5. Then you compare them to take a decision whether or not you should make a race selection. You apply this. In this case, I actually explained everything, but the offset part I did not. I think I can do it. It doesn't harm if you do it now. The offset is used to bias a cell. For some reasons, the network may want that a particular cell, or maybe for example, a cell is pretty highly loaded. So then you want that less people switch to that cell. Less people remains connected to that cell. Although you are now, it's all about RC state. Radio resources are not used, but you are made to be to initiate some activities anytime. As long as you are a regular user, you are a user because you may need some communication. So you may initiate some communication. So that you'll initiate on the same cell, adding some load to that cell. So here you may bias some cells which are underloaded, and you keep some cells free which seem overloaded or highly loaded. So that you do this way. For these different cells, you give some few offset numbers. How you give these numbers, we'll see. I mean, basically, SIP type 3 to SIP type 8 are used for notifications related to service selection. Anyway, so different cells can be given different Q offset values. So when you rank the cells, neighbor cells with RN, they will take on different values. And you always add some hysteresis to your cell so that you don't leave your cell too often, or too readily. Okay. So, and some, different cells in the neighborhood can be biased in different ways with different values for their offset. But you know what? A lot of times offset value is set to 0. All cells are off. In that cell, all cells are have equal bias. Anyway, as we can see here in the example, you find a cell beta in two spaces. Then you and then you start a timer, as we explained last time. When the timer expires, then you switch. So using both hysteresis and timer, you try to prevent ping pong. But you see that there is also uh, another moment indicated here, was that, well, you don't start measurement of uh, your interfrequency cells unless the present cell falls below 11. Meaning that if your current cell is too good, then you just don't have to perform any measurement. You just don't think about reselection. You're too happy with your current job. So then you don't look at the job site. So when it uh, falls below certain level, then you start doing so that is occurring here. So this value is given on SIP type 3 as far as I remember. Okay, this value is given on SIP type 3. As I mean, you know that you are reading all these SIP types, SIP messages. So, you, as long as you are above that value, you don't start measurement. So when you fall below, then you measure other cells around, because that measurement also consumes some power. So you start measurement, and then you see that, well, another cell is better than yours. Okay, but you don't trigger anything because that is yet to be better, and you are ranking in, in your rank calculation. RS is still higher than RN. RS is still higher than RN, so you don't do anything. But at this moment, RN becomes higher. This one falls even lower, and RN now becomes higher. So you start the timer, and here you actually select another cell as your new server. Okay. Some sample calculation. The history was 4. You get 1 for the measured for neighbor cell. These are RSRT values. Minus 1, offset is 0. So RN is very higher, so we start the time. Now we'll see, I mean, this was the case when you were looking at a cell which is on the same frequency or on a frequency of equal priority. Okay. Now let's see what happens when the priority is not equal. Okay. I mean, the cell is on another frequency, or it may be on another rate, and the priority is not the same. It is either higher or lower than your current priority. Okay, then again some conditions are given for you to initiate the measurement. So we'll straight go to an example. Then we'll look at the text that explains. So now we have a 3D cell around whose priority is given. The priorities are given on the SIP. Whose priority number is lower than what you have on your current LTE cell. Okay, so an interrupt cell with lower priority. Well, first of all, you don't start measurement unless your current serving cell falls below this level. It's not intercept. So other frequencies, I mean, you'll be measuring. See, you had some threshold here. That was it for this threshold value was called this parameter name terms are as you can see, are exactly the same as you have in this page. So if you search in this page is intra-search, okay. So you find better. So for intra-cell, intra-frequency cells, that's the threshold. If you fall below this level, your current signal still fall below this level, then you start measurement of interfrequency. For non-intra, if you fall below this level, then you start measurement of other frequencies, interfrequency cells or interarray. You falls below and you start measurement. Before that, you had no idea about the neighboring cells. Okay, then two conditions have to be fulfilled for you to reselect. Now you're measuring, now you know how the neighboring cells are doing. But you can trigger, actually, you can start the timer when two conditions are fulfilled. But there, your current signal strength has to fall below some threshold level. And the neighboring cell has to be above the threshold level. If both of these conditions are fulfilled, then you think of triggering cell reselection, and so for that purpose, you start the timer. Over the timer period, always whenever you're running the timer, over the whole timer period, the conditions have to remain fulfilled. Both the conditions have to remain fulfilled. If that happens, then you trigger cell reselection to switch to the EMT cell. So here, the first condition falls fulfilled, falls below, and the CG cell gets better than this threshold. But it can also happen that the 3G cell has always been better. So when your LT cell falls below that level, at the same time, both conditions get fulfilled. The 3G cell has always been better than its threshold. The threshold says X low QMTS. That's the threshold. You see, the 3G cell has always been better than that. So you start measurement here, and then you find the conditions fulfilled when your current cell falls below the threshold for yourself. Okay. So then you just wait for the timer to expire, and then you reselect. So that's about high priority to low priority MTs. But if the other cell, the intrafrequency and interrate has the same conditions. Okay. The same way, the selection could happen. Some sample calculation. Some sample calculation. So if the interfrequency or interest cells have higher priority compared to your current, well, in that case, simple. First of all, you start measurement at once. There is one condition: is the other cell, the neighboring cell, fulfilled. That's what it has to be above certain level. It's a high priority cell. Practically, it may happen. You get this kind of condition because see, there are deployments, new deployments of new technologies on the old deployments, deployments of other technologies. So the border areas you have to manage. Some loading. Different type of cells are differently loaded. That can also give relative priorities. Also, the border conditions you have to. When you are exiting some 4G areas and other areas become 3G, or when you are entering. So these different types of conditions in the we have in downtown area where you try to put the users in 4G to keep them satisfied. So there are different types of conditions. So when say some 3D cell has become underloaded, then you can make it you can increase its priority so that the cells you switch to that cell. But when it is not the case, then you want that more of the UVs remain on 4G. So the priority can help you. And if the priorities are equal, then you see try not to leave your current technology because of that threshold. Okay. So it can also happen that the neighboring cell has was already better than the threshold level. So as soon as you start measurement, you find that the cell with the high priority is above its threshold level. So you immediately start your timer. So as soon as you start measurement, you also start your timer. And when the timer expires, that's the quickest possible. Now see from the SIP types. SIP type 5, I say that includes information of other LT frequencies. And SIP type 6 includes information of other 3G cells. SIP type 7 includes information of 2G cells. SIP type 6 includes information of CDMA cells or 3GPP2 cells. So how they do that? For SIP type 6, there is a list. Okay. In the list, there can be different records. For each record, the frequency is given. Okay. What frequency? That is the center frequency. Okay. And then, these are numbered. All the possible and the center frequency possible are numbered. Okay. So these are called ARFCN for 3G, EU ARFCN for 3G, EU ARFCN for 4G. Anyway, then you are also given the threshold values here. You are given the cell resolution priority for that frequency. And the bandwidth that frequency is also given. So these types of information are given for every frequency. Similarly, for 3G cells, there can be multiple. On 3G also, different frequencies can be implemented. So for all these frequencies on 3G are informed here. The frequency is given, the priority is given, and for itself, the threshold values are given. So these types of information are given for every 3G frequency. Now, if you are moving too fast, then what can happen? You are, well, this type of adjustment, provision for adjustment is available for both cell reselection and handover. So let me talk about it for the handover case. If you are moving too fast, the speed user, vehicle is moving at velocity higher than 100 miles. So what may happen then? You are crossing the boundary. Okay. I mean, ideally, you should trigger the change of self or either self-selection or handover right at the boundary. Then you will have the best radio link experience because as soon as you cross the boundary between two cells, if you have ideal coverage areas drawn on the paper, when the vehicle crosses the boundary between two cells, the older cell is then further and the new cell is closer. So the radio link will be better for the new cell. So you should switch to that cell. So ideally, as soon as you cross the boundary, you should also switch. Okay. Now see, to prevent ping pong, we need to allow some margin. And there's also tier selection, I mean, for the same purpose. So what will happen? The handover will be delayed or cell selection will be delayed because the new cell has to be better by that cell, by that margin, hysteresis. And then you can consider cell selection. And right then you will not also trigger cell selection. You will start a timer. When the timer expires, okay, that confirms that the other cell is better and then you switch. But this confirmation costs you some delay. That delay may be okay if you are a pedestrian because you don't go far into the new cell. And so until you switch, you are connected to your old cell. So the radio link from the old cell is still pretty good. It didn't fall to some very low level because you're a pedestrian. You didn't go too far into the new cell. But if you are moving very fast, then that delay will cause you to move much deeper into the new cell when you switch to the new cell. And I mean, by the time you switch, okay, you are actually far away from your old serving cell. And so the radio link quality, you're connected to the old cell, and the radio link may fall too low by the time you switch. And what may happen, it, it may cause radio link failure. Okay? So, or if you were, in RC connected state, the radio link the quality may fall too low, so the data rate may also fall too low. Okay, this may hamper the communication. So there can be radio link failure, or there can be sudden drop in data rate. Okay, this type of things can happen. So for speedy UEs, some measure can be taken, or some additional features are incorporated in this page. But there, the UE can keep track of the number of changes, number of reselections over every certain time period. So if the number of reselections are too high, then it assumes that it is moving too fast. Then what it does, it reduces the margin, the hysteresis and the selection time period are scaled to some lower value. So depending on the number of cell reselections, it categorizes itself. Everything is occurring at the UN. So normal means no scaling. Medium means if the number of reselection exceeds certain number, but it remains certain. It remains below certain level within certain duration. That duration. All these values are these are some parameters you can configure by the network on SIP messages. So if the number of cell reselection is within this range, higher than this value and lower than this value, okay, in this period, then consider itself in the medium mobility state. This whole feature is optional though. And if the number exceeds this NCR age value, then it considers in the high mobility state. If it is below then it is normal. Then you can scale. The Q hysteresis will be reduced by certain value. That value is given by the network. And it gives what value is reduced for medium mobility state and what value for high mobility state. So you add this value, meaning that it reduces. Q hysteresis will be reduced by. Similarly, T reselection will be multiplied by one of these values. One will be given configured for medium mobility state and one for high mobility state. Okay. That's how we take care of the problem. Now we'll talk about handover. Well, we previously showed that there are interfaces called X2 between two e-nodeBs. In the neighborhood, all e-nodeBs are connected to each other. And the interface that connects the e-nodeBs, the neighboring e-nodeBs are called X2. And the interface that connects the e-nodeB with the core network is called S1.
Sir.
Yeah.
So I have a question regarding selection and other. But this calculation, sir, in which layer of communication this calculation takes place?
Very good question. Layer 3 does all the calculation. Layer 1 is measures and gives a message within the UE. I mean, these things happen. The layer 1 creates a message. In that message, the measurement values are all quantized. RSRP or RSRP values are included in the message, and it forwards it to layer 3. And at Qualcomm, I could see this message. These messages are not sent over the air. So, I mean, with many tools, you can't see these messages. These are internal messages between the layers. But I mean, some tools capture these messages too. Okay, I mean, these tool vendors have some negotiation with Qualcomm, with the chipset vendors. So, which messages the tool will be allowed to capture? Over there, messages will all be captured anyway. Then, what internal messages between layers can be captured? So anyway, it just sends. Say for cell reselection, it measures and it sends the message to layer 3, and layer 3 at some point of time takes decision. So all these things I could see myself.
So layer 3 is PDCP, right, sir?
No, it's above PDCP. Layer 2 has 3 parts: MAC, RS, and PDCP. And above that, layer 3, which is called RRC.
Yes, sir.
Radio Resource Control.
So it will be
the master layer.
It will be on a user control protocol, right, sir?
Well, I mean, how it operates is already configured in the chipset. So, I mean, as a user, you have no control over that. You can't change the rules. The chipset vendors, they follow the specifications, and accordingly they write the codes. Okay. So it is built in the firmware. You can't make any changes there.
So, sir, after calculation, the message will be transmitted in control plane protocol stacks, right, sir?
Well, we have so far discussed only cell reselection. So our cell layer makes the decision. Okay, when it finds another cell there, okay, like here, it decides that I should switch to that cell. It just starts considering this cell as its new serving cell, and it doesn't notify. In the case of cell reselection, the network is not notified because that notification costs radio resources. That's why we call it cell reselection. Whenever notification occurs, it is handover. So the network doesn't. The UEG is just considering that cell as its new serving cell. It camps on that cell. Got it? So RC layer decides that this is now my serving cell. Got it? Makes
Yes.
sense? Yes, I was also surprised when I first knew this thing. Well, now we'll delve into the second part, handover. Little more complicated. First of all, we have to handle the path for data. Now, the handover can occur using the X2 interface or S1 interface. Now, but the X2 interface may not be there always. It's not guaranteed that X2 interface will be available between every two nodes. So if it is there, then typically you use X2 interface. You take the advantage of the X2 interface. The handover will be actually quicker, and especially the packet loss. We'll talk about some other things that during the handover procedure, there are chances of packet loss. So that can be better protected in X2 based handover, or more easily protected. Now, if it is if you don't have X2 interface, then using the S1 interfaces like the older technologies, X2 interfaces, the interconnection among the inode bits are not available in 2G or 3G. So all the inode bits are connected to the core network, and those connections are used for the handover. So then, this one is. Now we say that for in RC connectivity state, the network will make the decision, but the UE will make the measurement. So the UE has to send measurement report. This measurement reporting will start like you can make measurements, but when you when you start sending measurement reports to the to your inode, your serving cell, depends is dictated by some rules. So there are actually two types of rules. One is called event triggered, the other is called periodical. If it is periodical, then you just at some regular interval, you just keep sending your measurement reports, which include the serving cell radio link condition and the neighbor and the strong neighbor cell condition. It's a list. So this cell PCI and the radio link RSRP value. Listed somewhere that includes PCI. Yeah. So it includes PCI, RSRP, and RSRP. But when it reports 3G cells, it reports PSC, and similar to RSRP, it has RSCP. Similar to RSRP, it has C by N. It is C by N. And for 2G cells, it includes ARFC and BC, which is like PSC or PCI, ARFC and BC set. And the signal strength, which is like, equivalent to RSRT, you have RSSI. And that C by I is not used for 2G. So anyway, that's what the measurement report infers. Now, more commonly, it uses event-triggered measurement reporting. For LT cells, intra-frequency cells, or interfrequency or inter-rate cells, or interfrequency or interfrequency cells, the events are event A types. For inter-rate cells, they are event B types. And there can be, there are 5 choices. So most commonly, the network asks you, the network says which one you should use. So most commonly, event A3 is used. So now you see, periodical measurement reporting is less common. So event triggered is more common. And among event triggered types, event A3 is more common. But there's the simplest thing, that when the neighbor cell becomes better than the serving cell by an offset. Okay, so like before, so you have some hysteresis. Okay, so here we call it offset. So by some margin, your neighbor cell becomes better. Then you start sending measurements. Until that, you don't do that. Measurement reporting also costs radio resources. So previously, between layers, the information was exchanged, but now you have to exchange information over the air using radio resources. So measurement reporting, you start only when you really require to do so. So when the neighbor cell becomes better by some margin, but if the network configures event A1, then you start. Sorry. I need to check event A1. Let's look at event A2 when the serving cell becomes worse than a threshold. Event A4 when a neighbor cell becomes better than a threshold. Event A5 serving cell becomes worse than a threshold, and also neighbor cell becomes better than a threshold. So both are fulfilled, then you start sending measurement. Similar conditions are also available for inter-rate neighbor cell better than some threshold. Just there are 2 types. Serving cell is worse than a threshold, or neighbor cell is better than. And again, you have another timer. It's called time to trigger. When you find that condition fulfilled, that the neighbor cell is better, say for event A3, neighbor cell better by the offset, then you actually start that timer, time to trigger. And when this timer expires, while continuously fulfilling the condition, okay, for the event, then you start sending measurement reports. So time to trigger is again some delay in the procedure, but to make sure that you really need to send the report. And handover decision is made by the E-node, but it's not specified in the statement how the network will do that. So there's nothing in the specification. So it depends on the operator implementation. But the way it does that, say usually, the net operates configured this way, that the report has to show that certain neighbor cell is better than the currently serving cell by certain margin. It sets a margin within itself. And this type of measurement report, it receives continuously uh, for certain, actually for certain number, maybe 4 or 5 measurement reports. Like while I was at Qualcomm, usually say 4 or 5, okay, but it could be adjusted. Usually say 4 or 5 measurement reports with the neighbor cell continuously better than the serving cell triggered the handover. So I mean it is on the network side, the network is receiving measurement reports from the UV. So when the network finds consecutive 5 measurement reports with a neighbor cell, each of them showing a neighbor cell better than the serving cell by certain margin, then the network decides that handover should be made. And then the network sends a command to the EV. Go ahead and perform this handover. The EV has to obey that command anyway. So the network sends the command this way. But that number is not fixed. Okay, 4, 5, these are some rough numbers.
Sir,
Yeah.
If it is in X2 layer, then the decision will be made by eNodeBan. If it is in S2
Well,
action change, then it will be made by MEME.
no, the decision will be made by the eNode base anyway. But for data, I mean there is also in the case of handover, there is also involvement from the core network. You have to change your data path. We'll shortly show you the involvement. Okay. You make the decision within your RAN. The decision, I mean, this RC connection reconfiguration complete message. This one completes the handover. The handover is completed here. So the network, the core network, I mean, it's not completed. What should I say? It's the, I mean, the handover decision is already made. Okay, and these are some early messages for the handover. So you see, the coordinator is not yet involved, and this RC connection configuration complete is, is completes the access to the new cell. Okay. But you have to route data, and the route is data via the core network. From the internet cloud, the data doesn't fall directly to the eNodeBase. The data is routed via the core network in both downlink and uplink. So the core network has to be involved. And so you see that in the rest of the flow, in the rest of the procedure, you see that the core network is involved, both enemy and serving gateway. So you have some now uh, the communication between source eNodeB and target eNodeB. Okay. This procedure, it is within the RAN, but this negotiation between source eNodeB and target eNodeB, this negotiation has to can take place if it is X2 based. If there is X2 interface, then this negotiation can take place over X2 interface. But if X2 is not available, then this one takes place via the core network. That's what it means. Okay, well, I should put it this way. That we talk about this negotiation. ENode is negotiating with the handover. That negotiation takes place over X2 interface. If it is X2 based interface. Even when X2 based interface, S1 based handover is possible. The network may configure the X2 based interface. It may still avoid in the early deployment. It may still keep S1 based interface. S1 based handover. Okay. Now, universal list (NCL) is something provided for the inter itself. Other, say for other frequencies. Inter, first of all, you are on a particular frequency, say some 20 megahertz, 80 frequency. That may be enough, but there can be another so inter frequency, another frequency. So that frequency will be informed, but the identity of the cells, say PCI of the cells of that frequency will not be informed. The PCI of your cell of your frequency will also not be informed. But this was not the case in 2G or 3G. In 2G or 3G, some NCL neighbor cell list was given. See, you are on it, for all the cells around to which you may have to switch were given. The network is to notify. So you don't have to look for the cells. You already know. You just see whether or not these cells are available around. Okay, but searching a cell takes a while. So, to make the procedure faster, the older technique is to give neighbor cell list. But the problem is that in the radio environment, I said before that the signal propagation, where the signal ends, nobody really knows. The signal people can't see. So sometimes it happens that I actually have experience with that. You find somewhere you find signal better from a cell, but that cell is not included in the neighbor cell list. The neighbor cell list will be provided by your current serving cell. So because of some shortcoming from the radio planners, which is not very unlikely in the real world, so the neighbor cells list sometimes miss the appropriate cells. The environment also changes because of some growth of new buildings. So anyway, so in that case, it may happen that you are not switching to the best cell because that cell is not included in the cell. This is called missing neighbor cell problem. So that so LT circumvent that problem. What it does not it doesn't provide neighbor cell list for LT frequencies for either intra or inter frequencies. Rather, the UE itself finds the cells around, as it does when you first power up, right? It finds all the cells around, so it can do that. So it does itself. So there won't be any problem of missing the appropriate neighbor cell. However, the internet cells are informed. Okay, the PSC, so they are provided. So there's a neighbor cell list for 2G or 3G cells. Adjustment for SPDE is also available in the handover case. Okay. But in this case, you adjust only the time to trigger, which is what you use which is a delay to initiate your measurement reporting. So that is a scale. If you are moving fast, again like before, you measure the number of handovers, and based on that, you set your state, medium or high, and then accordingly scale. You reduce your time to trigger. So for handover decision, okay, the network may also take other things into account. May not be only the radio link quality. Different cells may be differently loaded. Okay. So it's up to the network how it makes the decision. Now, what happens? What are the steps in the procedure? Well, first, the network sends you how you should measure. Say what type of measurement reporting you would do. Say even A3 or periodical measurement. So these things are configured. And To send measurement report, you need some resources. That resources are also given here in PDCC8. So then accordingly you send measurement reports, and say a number of reports may make the source inode feel that handover should be made, and it knows which inode we should switch to. It sends a handover request. Okay. And the target inode, if it feels that okay, you can do that, then it sends handover request acknowledge message, and that message includes some information. When the inode sends the handover request message, it includes the current bearer information. What type of, you will be using different types of data bearer, right? So that has to be accommodated by the new inode. It has to support those bearers. So this bearer information is also the capability of your UV. The different user have different capabilities. These things are informed, right? You see that handover request message includes information the readers and the capabilities. So if the new inode feels that okay, then switch. It sends a message, but that message includes actually the handover command. Okay. Because to access the new cell, it will tell you how you should access me. The target inode will tell the EU how the EU should access that new cell. So there are some configuration parameters. So it says that okay, you go ahead, you ask him to switch to me and use these configuration parameters. So it actually creates a whole handover command message. That handover command message is piggyback on this message. Okay. So then the serving source inode detaches that message and forwards it to the EV. The EV from there finds out. Usually it uses, now we know the random access procedures, that it can be either dedicated or contextual. Usually it is dedicated. In that case, this message includes the dedicated preamble and also the branch resources it should use. So those things are used by the EV. It uses random access procedure using that preamble and branch resources. But if it is if the target inode does not include this information, okay, then the EV recognizes that I should do the contention based random access. Okay, and now then you see the message 3. I say then okay, we're discussing random access. That message 3 is RC connection reconfiguration complex, which acknowledges this message. Okay, so this RC connection reconfiguration message here acts like a handover command message. And this RC connection reconfiguration complete message is an acknowledgement of that handover command. Okay, now I'm also fine with the handover. So at the radio interface layer, handover is already negotiated. So the data transfer can initiate there. Okay. And before that, so data forwarding can also initiate, but it is true for X2 interface. Okay. So over there, you can have some data forwarding because some data is coming to source inode from the core network. The core network is yet to know that now target inode is serving. So core network is delivering data to source inode, and the source inode will be forwarding them to target inode. But the target inode then say negotiates with the network for data path switch, and once it is complete, then the serving inode starts sending data to the target inode. Stop sending, sends path switch request to MME, and MME asks serving inode to switch its path. The serving inode are sending back data to the target unit. Okay. The end markers, okay, these are used for the, since you have data, okay, now initiated from the other end. So how you mark the, okay, the old data from old path and the new path, okay, so you can combine correctly, you can put them in proper order. So you need some end markers within the network itself, and accordingly you work them. Okay, and there is something that we will discuss the next day. That it's a some packets. There are still chances that some. Well, let me put it this way. In the days of 2G, handover invariably caused some loss of packets. I myself experienced, okay, at Qualcomm lab, that there is no way you can avoid losses. Some packets will definitely be lost. That's how 2G acted. Because you switch to a new cell, no matter how fast you do that, okay, there will be certain cause of, I mean, there will be certain period when you are not connected to any node, any base station. So you lose some packets. But these things are to avoid this loss of packets. What 3G did, it introduced soft handover. Okay. And the old method was then called hard handover. In the case of soft handover, you create new link with a link with a new base station. Start data transfer also with the new base station, and then you remove the old link. So for certain period, you have data transfer over both links. This is called soft handover. So that could actually completely avoid packet losses. But it was costly, especially when you have high data rate. So gradually the data requirement became extremely high. So this became too expensive. And sometimes with the 3G protocol, sometimes you can be connected with 3 or even 4 cells together as you are doing soft handover procedure, because you are not exactly sure which cell you should end up with selection. Which cell can be the best? So 2, 3, even 4. A lot of times 3 cells are connected together, as we experience. So data transfer concurrently occurred over all the 3 interfaces. So what 4G did, it stopped soft handover and went back to hard handover, because the high data, I mean, the fat pipe of data transfer cannot be accommodated. It will be lavish, it will be luxurious to support soft handover with 4G data rate. GBPS is the, GBPS data rate, you can support from 2, 3 nodes. So what it does, it created an option that if it is some, delay, if it is not error sensitive application, I'll finish in 2 minutes. If it is not error sensitive application, then you don't do anything. You just keep the loss of packets. But if it is error sensitive application, then you have an option to store the packets. Okay. During the pause period, when you have pause of, while you are not connected to anything. For handover, definitely there will be a short break. It is break before make. Soft handover means make before break. So in this case, there will be, if you break before make, so there will be short break. But during this break period, you store data in both downlink and uplink. In uplink, the UE stores data, or downlink, the eNodeB stores data. And when the new link is established, okay, you first send the stored data and then new data. So the source eNodeB will be forwarding data to the target eNodeB. The stored data will be forwarded to the target eNodeB, and the target eNodeB will deliver them to the EV. And the EV will also first send the stored data, buffer data, then the data newly arrived from the application. So this is why I'm showing here is status transforming, data forwarding. Anyway, there is, but to combine this data perfectly, there's some delicate steps, and PDCP layer actually takes care of this combination. And we can discuss that, but in the next class. Questions?
Sir,
yeah.
I have a question and a request. So first is that it would be better, sir, if you turn on the Zoom background noise suppressor. So it will be it will clear the audio of yours, sir.
Oh,
because many noises are come.
Oh, well.
Yes, sir, there's option for.
Oh, I don't know how that has got activated.
No, sir. I mean, I'm saying I'm requesting you to activate that noise suppressor. So it will cancel out your background noise and it will only transmit your audio.
Okay. Just tell me how I can do that. Which option?
In audio settings, you will find background suppressor.
Okay, from next class I'll do that. I found.
Also, sir.
Yeah.
Sir, about the lab quiz I talked with you. Did you talk with Nafis sir? About the lab?
No, not yet. I'll do that for this class.
কারণ স্যার নাফিস স্যার হচ্ছে স্যার ওইরকম ক্লাসরুমে বলে দিলেন যে 31 তারিখের আগে তাকে ডেট দিতেছে, মানে আমাদের তো স্যার কোনো লেভেলই ল্যাব কুইজ হচ্ছে না স্যার, হার্ডওয়্যার রিলেটেড যেগুলো মানে আমাদের রুটিনটা হয়তো বাদে স্যার, সামনে কয়েকদিন মানে খুবই মানে অবস্থা খারাপ স্যার। এর মধ্যে যদি ল্যাব কুইজে দিতে হয় আমরা ধ্বংস হয়ে যাবো স্যার পুরো।
Well, I was supposed to talk to Nafis and I'll do that inshallah today. But I don't think you guys will be destroyed. You guys are smart enough to take care of pressure, like the situation.
স্যার আমাদের আসলে স্যার পুরো ডিসেম্বরের
to get you guys destroyed, we need to bombard, right?
If the lab quiz is taken in February after the semester final, there is no problem, sir. After the semester final, the whole time is allocated for the lab, sir. 1 month time in the academic calendar, sir. So we can do the lab easily at that time, sir. How much we want, sir? As much as we want.
Yes, sir.
Okay. I'll talk to Nafis.
Since the lab is based on hardware, so we can slightly delay it after the exams. And the lab quiz, we can take it after the exams.
Let me talk to Nafis. I'm not officially teacher for the lab course, okay. But I'll discuss and that may help. Anything else that I can help you with? Where are we supposed to take our third class test? I forgot.
স্যার এই কুইজটা স্যার মানে একটু 23 তারিখে থেকে অন্য কোনো ডেটে নিলে একটু বেটার হতো স্যার, কারণ আমাদের রুটিনটা খুবই বাজে হয়ে গেছে স্যার, মানে ওই কম্পালসারি কোর্সগুলো স্যার
নো প্রবলেম, ইউ জাস্ট
একটার পর একটা মানে আমাদের মানে ডেট দিয়ে রাখছে।
ডিড ইউ সেট এ সিলেবাস
স্যার আমরা কি স্যার একটা অ্যাসাইনমেন্ট নিতে পারি স্যার? আমরা কি স্যার একটা আমরা যদি
স্যার অ্যাসাইনমেন্ট দিলে আমাদের জন্য অনেক ভালো হয় স্যার অ্যাসাইনমেন্ট।
Yeah, everybody likes assignment, but I myself don't, because it's very difficult for me to give an assignment. Okay, it's my shortcoming. It's difficult for me to give an assignment with which I can judge fairly. Fair judgment is the most important thing to me for the purpose of grading. And I mean, very difficult. I have to create real challenge that that becomes well, that becomes an individual challenge for everybody. Okay. And also, even that sometimes doesn't help. I mean, sometimes you guys are so good trained, okay, that after solving your problem, you may solve problem of your friend. Okay. Uh, so it is difficult to have good judgment, to have fair judgment. So let us take class test and let us scale. Okay. So because at the end, I mean, the good students will be deprived if there is no, if the judgment is unfair. Okay. Then I mean, poor students may get some benefit, but actually some good students are actually deprived somehow. If you understand how it is the case. So rather, let us use our regular class test and a little scale so that nobody really suffers. Okay, sounds good.
Sir, when will we start 5G possibly, sir? From which
From
class?
next class, from next class.
Oh, okay. Thank you, sir.
I have actually a short presentation left that will take maybe like 10 minutes. That was sort of related to handover. So in the order, I put it after this one. Anyway.
Sir, I have a question that in one of the class you mentioned that GP transmits the original IMSI in the air. They do not use any other alternate code. Isn't this a huge security concern?
Yeah, it is. Definitely it is.
Anyone,
but nobody knows that it does it.
With some cheap technology, anyone can get the IMSIs and can employ a major attack like DDoS attack. Jamming all the nodes be in one country. I mean, it's possible.
I also agree with that. It is a cheap technology that you need that. Okay. And you know what? How I came to know? A couple of my old students, okay, working at GP, they purchased some device that cost them like 2,000 to capture the message. Okay. And then they just code it, okay, so the messages are properly displayed. And then they showed me that, see, in our network, they showed me their paging messages. I mean, we'll show in shortly like Excel, which captures the messages. But they did not have this expensive tool. Okay. So just some cheap tool they use to capture the message and see that you have the IMSI.
So I think
additional actions can also be done by the eavesdropper. So once you detect the user, you can also hamper their data transfer using similarly cheap technology.
So cloning can also be possible, right, sir?
Sorry?
Cloning, IMSI cloning.
A lot of things are possible, and people did that a lot until 2G days. Okay, but you know what? When 3G started, these eavesdroppers, okay, found their life very difficult because the security measure became very high for 3G, and also since 3G uses scrambling, okay, coding and scrambling both together creates another level of security. Okay. It became very difficult for the for the people to decode. Someone, an operator, he was actually the CEO of an operator in our country. He told me that they were actually doing they are capturing, for some purposes, they are capturing 2G data from the air. But when 3G started, they failed to do that any longer. Just because of this additional. The basic security measure was the same, almost the same. But because of that. So since then, this is dropping, it's become almost nil.
So
Yep.
using 4G module, we can read the paging message from the air, right, sir? 4G module and microprocessor.
Well, you know what? The messages I saw actually were on 2G network. IMSI, GP was providing IMSI. They were on 2G network. Okay. So on 4G network, actually they won't be able to decode the message because of additional security. Got it? IMSI is there, but breaking the security is not that easy. You have to first break the security, then you read IMSI. You don't use IMSI as an additional protection measure, additional security measure. You don't express your identity. So the bottom line is that there is very high level security. Okay, so I think if you have already planned for hacking, you can leave your plan. Got it, Ratul?
Yes.
You can stop trying to hack, I think.
I think for security purpose, it will be a good experiment, sir.
Yeah, but I mean, to me, it seems like you're planning to hack. That's what
I mean, sir, every technology has its backdoors, regardless of who develops the technology. Or
maybe. Yeah, maybe Ratul wants to know what we discussed in our departmental meeting. Okay.
not like this, sir. I mean, people's security should be our concern, and there should be research done in this field to enhance the security of current technology. That's the purpose, not to hack into people's cell network and listen what they're doing in their private time. So that should be not our goal.
Yeah, definitely. If you come to know what bad words my wife uses when she talks to me, then you won't. It will be really embarrassing, very embarrassing for me. Okay, what else?
Sir, have you checked your mid papers?
Sorry?
Mid papers.
Oh, not yet. Inshallah, shortly, I will review. I just need to get more organized.
Okay, thank you. So,
Okay, so let us wrap up for now. Thank you for your time.